Hello. Yeah, good morning, everyone. So, how was the quiz too?
Good.
Yeah, okay. Any other student? How was quiz two paper? Uh, Sorry, Loknath, you are not audible properly.
Yes, sir. Good. Sir.
Okay.
Hello everyone. Good morning everyone. Hello. Am I audible?
Yes, sir.
Yeah. So I hope everyone watched lecture 10.2 and 10.3. So any doubt? It's the 10.2 and 10.3.
So yeah, hello, good morning. So today's session will cover locking protocol, transaction time machine. Then if you have any doubt, you can ask. So let me share my screen. So my screen is visible, right? Hello.
Yes.
Okay. So locking protocol. So a lock is a mechanism to control concurrent access to a data item. Why you are using locking protocol? To achieve serializable, we are using concept called locking protocol. So basically, whenever transaction want to perform any operation, whether read or write, before performing any operation, it should apply a lock. There are two types of lock. One is shared lock and second is exclusive lock. So what is shared lock? If transaction want to perform reading on any data item, it should apply a shared lock. Suppose transaction T1 want to perform read operation, right? So it should apply shared lock. Will return as lock shared lock. So shared lock return as like this lock then shared lock. If any transaction want to perform only read operation, then we can apply shared lock. Everyone got it? What is shared lock?
Yes.
Okay. Now we'll move to the exclusive lock. If transaction want to perform reading or writing or both operation on any data item, it should apply exclusive lock, right? So suppose transaction T1, I want to perform write operation or read operation, it should apply exclusive lock written like that. Okay. If you have any doubt in the middle, you can ask. Okay. So then we'll see locking matrix. So suppose there are transaction T1, T2, T3. If one share lock is applied and read A, we can apply transaction in transaction T2 or other transaction share lock, right? If you want to write, so more than one share lock is possible. Everyone got it?
Yes, sir.
But one share lock is already applied. If you want to apply exclusive lock, it will not allow. So if on any data item, suppose on a data item, share lock is applied. If you want to apply exclusive lock, it will not allow. Right? Then the exclusive lock. Suppose there are two transactions, T1 and T2. If already apply exclusive lock, right? If you want to apply share lock, it will not allow. If you want to perform share lock, it will not allow, right? And same as if you want to apply exclusive, it will also not allow. So everyone got it, this lock matrix? This is very important.
Yes, sir.
Okay. So important point is multiple share lock is possible. Multiple share lock is allowed. Right? So let's see example. So suppose there is a one schedule S, and there are two transactions T1 and T2. The lock share lock applied, then read A, then lock share lock applied, then read B, and unlock A, right? Then exclusive lock, then read A, right? And the unlock A. So is this valid? Is this follow locking protocol? Anyone? Hello, am I audible?
Yes, sir. This is possible.
Because before granting lock, we have unlock A. You can see that we have share lock A then lock B. Then before transaction T1 on perform read, read and write also. So before locking T1, it's T2 unlock. Let's take another example. Suppose there are one is schedulers and transaction T1 and transaction T2, right? So exclusive lock XA, then read A, then write A, and suppose transaction T1 perform shell lock and to perform read operation, then read B, and transaction T2 perform write operation on B. So exclusive lock B, then write B. So is this follow locking protocol? Then unlock. Anyone?
So T1 hasn't been unlocked, means
Yeah, it not been unlocked, so it does not follow locking protocol. So before locking T2, it should be unlocked. If it is unlocked here, then we can allow this, right? So everyone got it? Locking protocol, share lock, exclusive block. Am I audible?
yeah, it's clear.
Okay. Now let's take another example. Okay. So suppose there are schedulers and there are two transactions, T1 and T2. So suppose transaction T1 perform write operation on data item A. So write A, then unlock A. Suppose transaction T2 read operation, write operation on T2. So lock XA and write A, then unlock A, and transaction T1 want to perform read operation on data item A. And read A, then unlock. So is this follow locking protocol? Hello.
Yes, sir.
So now the question is this conflict serializability? Is this conflict serializability or not? Anyone? Anyone? How to find this is conflict serializability or not?
So for conflict serializability, you can means exchange read write operations.
Now, is this schedule conflict serializability or not?
So sir, how will you exchange lock A, unlock A, these operations?
No, see, this is so you have to draw precedent graph, right? So there are T1 and T2. So you can see that what are the conflicting instruction? Read A, write A, right? And write A, right? And write A, read A, these are the conflicting instruction, right? So you can see that WA and the W right A. So you can will draw precedence graph. You can also see that WA and read A. So this is the conflict instruction. So this precedent graphs from cyclic, right?
Hmm.
So if it is from cyclic, then it is not conflict serializability. If it is a precedent graphs from acyclic, then you can say that this is conflict serializability. This is not conflict. Everyone got it? In the previous session, we have discussed how to draw precedent graph, how to find a schedule is conflict serializability or not. So everyone got it? This how to draw a precedence graph.
Yes, sir.
Okay. So locking protocol does not ensure uh, conflict serializability. That's why you are going to two-phase locking, right? So everyone got it? Why you goes to two-phase locking, two-phase protocol or two-phase locking protocol? So a transaction is said to be follow two-phase locking protocol. Is locking and unlocking can be done is two-phase, in growing phase and the shrinking phase. In the growing phase, transaction may obtain lock, and the shrinking phase, transaction may release lock. Sorry. In the growing phase, transaction may not release lock. It cannot be released lock, and shrinking phase not obtained any locks. So everyone got it? What is two-phase locking protocol? And there are some important points. After shrinking phase in two-phase protocol, growing phase is not possible. And growing phase is compulsory, and shrinking phase is optional. And there are very important one, two-phase protocol, uh, uh, two-phase locking protocol always conflict serialization. So let me give one example, you will understand. Okay. So let me give another example here, right? So suppose there are transaction T1 and T2. Exclusive lock applied, right? Lock exclusive applied. Then read A, write A, right? Then unlock A, right? Then transaction T2, exclusive lock apply on uh, B, sorry, share lock on B and read B, then unlock B. So is this follow two-phase locking protocol? You can see this. What is growing phase? It may obtain lock, right? So we can see that this is the growing phase, and this is the shrinking phase in transaction T1. And this is the for transaction T2. This is the growing phase, and this is the shrinking phase. So you can see that uh, this transaction in two phases, growing phase and the shrinking phase. After the growing phase, after the shrinking phase, growing phase is not possible. So there is, after the unlocking, there is no growing phases. In transaction T2 also, after the shrinking phases, there are no growing phase. So is this follow to PL? Yes, this is follow to PL. You can see that this is a conflict serializability. You can also draw precedence graph. So there is no conflict instruction. So this is a conflict serializability. So everyone got is, how to see whether it's growing phase and the shrinking phase, and how to check this is 2PL or not.
Yes,
Yes,
sir.
sir.
Okay, so I'll give another example. Okay, so let me T1 and T2. T1 and T2. Lock exclusive applied. Then trade A, WA, then shall lock be applied, read B, right? Another lock shall lock applied, right? Then read B, then unlock B. Here's unlock B and the unlock A. Is this follow 2PL, two-phase locking protocol? Anyone? Anyone? Okay, you can see that this is the growing phase. This is the growing phase for transaction T1. And sorry, this is the growing phase. And this is the shrinking phase for transaction T1. And this is the growing phase. And this is the shrinking phase for transaction T1. After the shrinking phase, there are no uh, any transaction obtain, any data item obtain lock in T1 and T2 also. So this is follow 2PL. Follow two-page lock protocol. Right? So everyone clear with this?
Yes, sir.
Okay. So let's see, this is a complete serializability or not. So let's draw precedent graph T1 and T2. We can see that there are no conflict instructions. So this is a two-phase locking protocol. If there is, suppose if there is exclusive lock B, and there is write B and unlock B here. And this is also follow two-phase locking protocol. You can see that there is a conflicting instruction T1 and T2. So there is no cyclic. You can see, you can tell, you can, this is a conflict serializability. Okay. Now we'll see another example. Okay. Now T1 and T2. Suppose there is lock applied, share lock, then read A, then share lock B, sorry. Read B, unlock B, right? Then again XB, exclusive lock, and the write B and the unlock B. So again share lock applied. So is this follow two-phase locking protocol? Is this schedule?
No, sir.
So why? And can you explain?
Sir, first is a growing phase.
Yeah.
in T1.
So you can see that this is the growing phase, and this is the shrinking phase.
Yes,
So
sir.
yeah, transaction T1 follow 2PL, but you can see that transaction T2, this is the growing phase.
That's
Yeah.
and then sinking phase.
Yeah, sinking phase. Then again
growing phase.
growing phase. So this is not allowing two-phase protocol, two-phase locking protocol. So you can say that this schedule not follow 2PL. So everyone got is how to find this schedule is 2PL or not, and what is two-phase locking protocol? Why we use two-phase locking protocol?
Sir,
Yes,
can
sir.
you just
Yeah.
explain the conditions once more?
Yeah, can you repeat?
Sir, just the conditions mean these two-phase locking protocol conditions.
Okay, yeah. So see, in 2PL, in two-phase locking protocol, transaction is said to follow two-phase locking protocol. The locking and unlocking can be done is two-phase, growing phase and the shrinking phase. So after sinking phase, you can see that after sinking phase, in two-phase locking protocol, growing phase is not possible. So in growing phase, transaction may obtain lock. It may obtain lock, and in shrinking phase, transaction may release lock. You can see that in shrinking phase, transactions are releasing the lock, and after the shrinking phase, growing phase is not possible. This is the important point. After shrinking phase, growing phase is not possible. So you can see that there is a growing phase, then this is the shrinking phase. So after the shrinking phase, growing phase is not visible. So this schedule not follow 2 p.m. So you got it. How to check? This is the
Yes.
important point.
Yes, sir. Clear.
Okay. Okay. Everyone got it? Two-phase locking protocol.
Yes, sir.
And another important point in two-phase locking protocol is 2PL schedule. Sorry, two-phase locking, two-phase. But vice versa is not true. Okay. So now we'll see what are the disadvantages or the problems with two-phase locking protocol. We'll see with the help of example. It does not ensure.
Sir,
Yeah.
Sir, can I get this PDF? Where can I download this PDF?
Yeah, I will share.
Okay, sir.
So this does not ensure recoverability and does not ensure this there is a problem with cascading rollback and it may happen deadlock. So we'll see with the help of example, right?
So did starvation also something like that?
Yes. Hello, someone.
Starvation is also mentioned in the lecture slide.
Yeah. May there is a see. It may happen starvation also possible. Suppose one transaction is waiting, to obtain a locks in long time, so it may possible to starvation. So I'll see main points. What are the actual disadvantages? It
Okay.
may does not ensure recoverability, may cascading rollback and the deadlock, right? So we'll see with the help of example. Okay. So there is a schedule S and the T1 and the T2. And the lock applied, right? SB and also applied exclusive lock XA, then read B and the write A and the unlock A, right? And the yeah, exclusive share lock is applied, then read B, then exclusive lock is applied, then write A, then unlock B, unlock A, right? Here's suppose there is commit and here also commit. So if you see that, suppose transactions fails at this point, so we can roll back T1, but we cannot means we can recover T1, but we cannot recover T2 because already commit operation at this point, right? So we cannot ensure recoverability in two-phase locking protocol. You can see that this transaction is follow 2PL. This is the growing phase and for transaction T1, and this is the shrinking phase for transaction T1, and this is the This is the growing phase for transaction T2, and this is the shrinking phase for transaction T2. You can see that this is the follow to PL locking protocol, but it does not ensure recoverability. So everyone got it?
Yes, sir.
Okay. This is the important points. You can see that. So please try to respond. And second is cascading rollback, right? Suppose there are three transactions, T1, T2, and the T3, right? Exclusive block is applied. Then read A, write A, then unlock A. Then exclusive lock is applied. Read A, write A, and here also exclusive lock is applied. So you have to unlock, right? Unlock. Exclusive lock is applied and write A, unlock A, right? And C1 and sorry, C1 after the right, C2 and the C3. So check this schedule is two-phase locking protocol or not. So is this two-phase locking protocol?
Yes, sir.
You can see that this is the growing phase and this is the shrinking phase for transaction T1. And for transaction T2, this is the growing phase and this is the shrinking phase. And for transaction T3, this is the growing phase and transaction transaction T3, this is the shrink phase. Suppose this in this position, this schedule is failed, this transaction is failed. So can we recover T1? Suppose this point. Yes, we can recover T1 also. Can we recover T2? Yes, because now commit operation does not happen. So yeah, yes, we can T2, we can recover T2. We can T3, yes, we can also recover T3. But we can see that transaction T2 depends on T1. And transaction T3 also depends on T2, right? So because of one transaction failures, we have to need roll back all other transaction, right? So this situation is called cascading rollback, right? So in two-phase locking protocol, this cascading rollback may happen. So everyone got it? Cascading rollback?
Sir, it may happen,
Yes,
but
sir.
it's always not possible.
Yeah, it's always not possible. It may happen.
Okay.
We are reading, there are disadvantages. Suppose there is a 1 point, it may happen, so we'll consider, right? So it may happen cascading rollback. Okay. Now we'll see deadlock. Okay. Suppose there are schedulers. Transaction T1 and transaction T2. So exclusive lock is applied. Then read A and write A, right? Then in transaction T2, Exclusive lock is applied on data item B. Read B, write B. So suppose in this position, T1 now T1 want to update the value of B. B in this position, and T2 also want to update the value of A, right, in this position. In this position now T1 want to update the value of A and value of B, and T2 want to update the value of B. So let's write T1 want to update the value of B. And in this position, let's see this. In this position T2 want to update the value of A, right? So T1 will wait to release the lock B on T2, and T2 also will wait to release the lock on T1. So there are two transactions are waiting, right? This T1 transaction waiting for B and T2 transaction waiting for A. So in this situation, deadlock will occur, right? Everyone got it? Hello.
Sir.
Yeah. So in T1 also wait for the release the lock for T2. So T1 will wait for the B, and T2 also wait for the release transaction T1 release the lock A. So both will wait T1 and T2. So deadlock will happen. So two-phase locking protocol does not ensure deadlock also. Why deadlock happen? Everyone got it. Why actually deadlock happen?
Yes, sir.
Okay.
Yes, sir.
Okay. So now we'll see stick to pair. Stick to pair. What is stick to pair? This follow tuple locking protocol, and all exclusive lock should unlock after commit operation. And what are the benefit of 2PL locking protocol? What are the benefit? It stick to PL as 2PLs are recoverable. And stick to two-phase locking protocol are also generate cascadeless schedule. So what is strict 2PL? It is follow 2PL and all exclusive lock, not share lock. All exclusive lock should unlock after commit operation. It should be unlocked after commit operation. And what are the benefit? It is recoverable. You can see that 2PL are not recoverable, but stick 2PL recoverable, and stick 2-phase protocol also generate cascadeless schedule. So it is not cascading rollback. So let's see one example. So that will help. There is one schedule T1 and the T2. Okay. Exclusive lock is applied. Then read A and read B. W write A and the unlock B and the commit unlock A, right? And then lock is applied as B and exclusive lock, lock applied WA and the commit happens C1 C2 the unlock. So is this follow 2PL locking protocol? Anyone?
Yes, sir.
Yeah, you can see that this is the growing phase for transaction T1 and this is the shrinking phase, right? And for transaction T2 this is the growing phase and this is the shrinking phase. So let's see this is follow strict 2PL or not. So you can see that all exclusive lock. So exclusively A, so applied on A. So it should be unlocked after commit operation. So you can see that after commit operation, exclusive block is unlocked. And here also exclusive block is unlocked after the commit operation. So this schedule is follow stick 2PL. So everyone got it?
Yes, sir.
Okay. So let's see another example. Suppose commit operation after unlock C, after unlock A. So is this stick 2PL? Is this strict 2PL?
No, sir.
Yeah, because you can see that unlock exclusive of unlock A is before the commit operation. So this is the not strict 2PL. So okay. Now we will see rigorous 2PL. What is rigorous 2PL? It is follow 2PL and all locks either exclusive or share lock should unlock after commit operation. So regards to PL, it is follow to PL, and the all locks means it can be exclusive or it can be share lock should unlock after the commit operation. So what are the advantage of regards to PL? It's same means it it is that's it mean if it is regards to PL, it is recoverable schedule and it is no cascade rollback. So let's see one example, right? So suppose there is schedule S and that transaction T1 and T2 exclusive lock is applied. Okay, let's see this example. Sorry. So this follow S2PL, right? Hello. Okay. So is this follow regards to PL? Anyone?
No, sir.
Yeah, why?
Unlock B is not happening in T2. Is it?
Okay, we can see that all the either exclusive lock or share lock, it can be unlocked after the commit operation. We can see that it unlocked before the commit operation, so it cannot, it does not follow rigorous 2PL. Okay, so if it is unlock here, unlock B, so is this follow rigorous 2PL? And also it is follow unlock B here after the commit operation. Is this follow rigorous 2PL? Yes, it is follow rigorous 2PL because you can see that unlock of B, all the exclusive, it is where it is exclusive lock or share lock, it unlock after the commit operation. So we can say that this is the rigorous 2PL. So let's see another example also. Suppose lock XA, then write A, right? Then commit unlock A, then suppose apply lock share lock on B, read B, lock exclusive, write A, right? Then commit, sorry, unlock B, unlock A. So is this follow two-phase locking protocol?
Yes, sir.
Is this follow rigorous 2PL?
Yes.
Yeah, you can see that exclusive lock is unlock after commit operation. This is the growing phase and this is the shrinking phase. You can see that this is the growing phase and this is the shrinking phase, and the all exclusive lock in T1 or share lock, it's unlock after the commit operation, and T2 also exclusive lock on that item A, it unlock after the commit operation, and share lock of B unlock after the commit operation. So we can say that this follow 2p locking pattern. So yeah, so we'll see one example. So I will wait few minutes. You can solve this question. It is a very important questions. I will wait few minutes. You can answer in the chat, in the Zoom chat box. Hello, anyone got the answer? Okay, let me solve. Schedule as is given below. So there are 3 transactions: T1, T2, and the T3, right? Okay. Okay. W2P, W2P, right? Then W1P, then W1P, then W3P, then W3P, W2Q, W2Q, and W1Q, right? So everyone got it. So first, let's see second first. The given schedule as is complete serializable or not. So let's draw precedent graph. T1, T2, and the T3. So can you help to draw? Anyone help to draw precedent graph?
Sir, T2 to T1 will be there.
Okay, T2 to T1, because there is conflict instruction T2 and T1, and then
T1 to T3 will be there.
T1 to T3, yeah, because you can see that WP and that WP there is conflicting instruction. So yeah, T1 to T3 will be there. Then
And then T2 to T1 is already there.
T2 to T1, then yeah, T2 to T1 we have draw, right? Then
I'm not getting it.
okay. Okay. Okay, so is this okay, let's see one by one. W2P, then W1P, then we have draw W3P, right? Then W2Q and WQ. Let's see first. Yes, okay. So we have to see every transaction, right? So T2, you can see that W2 to W1 will be there because these are the conflicting instruction. So T2 to T1 will be there. Then you can see that WP and the WP, right? You have to go one by one. So you can see that W2 P2, so there will be conflicting instruction WP and the WP, right? So there one as will be T2 to T3. You got it? Why you got T2 to T3?
Yes.
Yes. Then yeah, then we have to see. Then you have to see this W1P. We can see that T1 to T3 there is a conflict instruction. W1 both are writing the both transactions writing the data same data item. So T1 to T3 there will be H. Then after that WP there is no WP, means read P or WP. You can see that T2 and T1 both are writing on the same data item. So there will be T2 to T1. So T2 to T1 already there. So is this graph cyclic or acyclic?
It's acyclic.
Acyclic. So this the given schedule is conflict serializable. Everyone got it? Hello?
Yes, sir.
Okay. Now we will see
Yes,
the
sir.
given schedule is 2P lockable or not. Okay. Let me erase. T1, T2, and the T3. So W2P. So we have to apply exclusive block, right? Exclusive block XP. Then you have to write P key, right? Then then you have to unlock, right? Unlock P. Okay. Then W1P, right? So you have to apply exclusive block. Exclusive block P and the write P. So up to what happened? Then unlock P. Everyone got it up to this? Okay. Then W3P, so you have to apply exclusive lock on P, on data item P, WP, then W2Q, right? So you have to apply exclusive lock. If you apply also in the here, if you lock XQ, if you apply it, we can direct right Q and the unlock Q, right? Then if to unlock, then up to then W1Q, right? So you have to apply exclusive lock on Q, then WQ. So is this follow two-phase locking protocol? Anyone?
No, sir.
No, why?
In T1, there is a growing and shrinking, and then growing and shrinking.
Yeah, growing phase. And then shrinking phase. After that again, growing phase. So this we can say that the given schedule is not equal. So this is not a right answer. Now we can answer the first. All conflict serializable schedule are 2p lockable or not. You can see that this schedule is conflict serializable, but this is not a 2p lockable. So you can say this is the wrong answer. So only one numbers of character statement is only one, and the second one. So everyone got it?
Sir, in T2 the lock for XQ, why is it happening there? Shouldn't it happen down?
Yeah. See, we have unlocked the P, right? So we want to try the 2p lockable. So if you apply here, if you apply lock XQ, then growing phase, then shrinking phase, again growing phase. So you can see that Q data item, none of the transaction are used, right? So if you apply lock Q here, so you can see that this is the growing phase. Then again, then shrinking phase. Okay. So that's why we've written so to follow 2PL. If it is follow 2PL, that's why you've written. You can also apply lock SQ here also.
Okay.
So you can apply here also. Anyone have any doubt in the locking protocol, two-phase locking protocol, rigorous to PL? Anything about locking protocol you can ask.
Sir, if it's rigorous, then it will be strict also, right?
If it is rigorous, it will be strict also. Because you can see that in strict to PL, follow to PL, and all exclusive lock is should unlock after commit operation. Only means does not talk about share lock. And the exclusive lock in the rigorous 2PL, all locks either exclusive lock or share lock should unlock after the commit operation. So all you can see that all rigorous 2PL are rigorous rigorous 2PL is strict 2PL, but vice versa is not. Okay. Any other doubt in locking protocol? Okay. So now we'll see timestamp protocol, right? So in timestamp based protocol in short, it means it does not occur deadlock. That's why we're using timestamp protocol. You can see both rigorous 2PL or strict 2PLs. It does not talk about deadlock. It can be occur deadlock, right? It in the S2PL is recoverable and cascadeless, but it can be deadlock, right? So to avoid deadlock, we are using timestamp protocol. So when a transaction enter the systems, each with each transaction T1 TI in the systems, we associate a unique timestamp when it enter the system. So suppose T1 enter the system, we associate a unique timestamp. It can be 1, 2, or it can be also system clock, right? So when it entered to the system, we associated a unique timestamp. It can be there are two ways to give unique timestamp. It can be system clock, or it can be logically counter, right? So suppose transaction T1 enter the system at 12, right? So you can give unique timestamp 12. If suppose transaction T2 enter the system 12:05, so you can enter 12:05 in the system clock, right? And logical counter, we can keep T1 1 also. If T2, it should be greater than T1 if it is enters the after the T1. If T2 enter the system after the T1, it will be greater than 1. So it can be 2, 3 also, anything. So each transaction is issued a timestamp when it enter the system. If an old transaction Ti has a timestamp transaction T1, a new transaction Tj assigned timestamp, it should be a timestamp of Tj should be greater than timestamp of Ti. So this will be the and another important point. A smaller timestamp will be the older transaction, and the a greater timestamp will be the younger transaction. So you can say this will be the T1 will be the older transaction, and T2 will be the younger transaction, right? So everyone got it. When it entered to the system, it issued to the unique timestamp to each transaction in timestamp based protocol. This point is clear. Hello, am I audible?
Yes, sir.
Okay. Okay, so let's give now we'll see next point. So in the right timestamp of Q, the right timestamp of Q is the largest timestamp of any transaction that executed write Q successfully. So right timestamp of Q will be largest timestamp of any transaction that executed write Q successfully. Recently write the largest timestamp, and the read timestamp of Q will be the largest timestamp of any transaction that executed read Q successfully, right? So everyone got it, right timestamp of Q and read timestamp of Q. So
Yes.
basically, yeah. So we'll move to the next. Okay. Suppose transaction Ti issued read on queue data item. Okay, so if transaction timestamp of Ti is less than write timestamp of Q, then Ti need to read a value of Q that was already overwritten. Hence, the read operation is rejected and Ti will be rolled back. So if timestamp of Ti is less than the timestamp of Q, then Ti will be rolled back. If timestamp of Ti is greater than write timestamp of Q, then read operation is executed and read timestamp of Q will be the maximum of write timestamp of Q and timestamp of Ty. So if timestamp of Ti is greater than write timestamp of Q, it will be the largest among the two value. So we will see with the help of example. If you did not understand, don't worry. So again, I'm explaining. Suppose that transaction Ti issued read operation of Q data item, then we will see this condition. If timestamp of Ti less than the write timestamp of Q, then Ti will be rolled back, right? And if timestamp of Ti, okay, let's see. Suppose transaction T1 issued read operation of data item Q, right? So you will see timestamp of T1 is less than write timestamp of Q. If it is true, then T1 will be rolled back. If timestamp of T1 is greater than write timestamp of Q, then read operation is executed and the will set write timestamp Q maximum among the two value. So everyone got this point? At least answer yes or no.
Yes, sir.
Okay. Then suppose transaction Ti issued write operation of Q. So we will see two conditions. If timestamp of Ti is less than the write timestamp of Q, then Ti will be rolled back. If timestamp of Ti is less than the write timestamp of Q, then Ti also be rolled back. Otherwise, system executed the write operation and set the write timestamp of Q will be Ti, right? So in the if transaction Ti issued read operation, we are checking only one condition. While if transaction Ti issued write operation, we are checking two conditions. Why? Anyone can tell why we are checking two conditions, write timestamp also and read timestamp also and write timestamp also? Why we are checking two conditions while issued write operation? Anyone? Because you can see that conflict instruction in the read case only write a write, because read a and read a will not a conflict instruction. So you are checking only one condition. While in writing, it can be two conflict instructions while read a also and write a also, right? So that's why we are checking two conditions. Everyone got it?
Yes.
Okay. Okay, so we'll see one example that will be better. Okay, so suppose there are two transactions T1 and the T2, right? And the one transaction T1 enter timestamps of one will this is 1 and timestamp of T2 is 2. When you enter the system gives unique value once and the 2. T1, then which one with the older transaction and which one with the younger transaction? Anyone?
T1 will be
T1
the
T1 will be the older transaction, right?
Hmm.
Sorry. And 2 will be the younger transaction. So right timestamps. So we'll and the right timestamp. TS and TS. Okay. Suppose there are two data items A and B. So initially, what we'll do? We'll zero all that, right? So suppose T1 want to perform read operation, right? Read operation on A. So we'll check. So first we have to check. We can see that read operation of A. Initially we will all set to 0. Read operation is 0, right? Read timestamp of A data item is 0. Initially we set all to the 0, right? Hello.
Yes, sir.
So 0. So transaction T1 perform to read operation. So you have to check this condition. Okay. So let me erase. So T1 and T2. This is the 1. This is the 2. Read timestamp. The right timestamp. There are two data items. Suppose AB 0 0 0 0. Right. Suppose T1 issue a read operation. So we have to check transaction TI T1 issue read operation of data item A. It will change. If it is A, then it is B. So TI1 issue read A, right? So you have to check. So timestamp of T1. What is the timestamp of T1? Is 1, right? Hello. Timestamp of 1 is 1. Where got my points? Everyone. Hello. This is a bit tricky. That's why I'm asking in each step you are getting or not. Hello. Am I audible?
So these timestamp values 1 and 2, these are different from these values 0, 0, and 0.
Yeah.
which are
See,
written.
yeah. When it enter to the system T1, so system assigned to the unique timestamp 1 and 2. It can be system clock or it can be logical counter also. So we'll 1 and 2 assigned, and the initially this transaction timestamp and the read timestamps are different, right? So transaction timestamps systems are assigned to a unique timestamps, and the read timestamp initially all are the set to 0 because none of the transaction is read the data item or write the data item. So initially all the read timestamp and the write timestamps are set to 0. So now transaction T1 issued read operation, right? It issued read operation. You can see that you have to check this condition for the read operation. T1 issue read operation on data item A. So you have to check this condition. So timestamp of T1 is timestamps of T1 is 1, right?
Hmm.
So we can check 1 less than what is the right timestamp of A? It will be A, right? So right timestamp of A is 0. 80, right?
Okay.
So 1 less than 0, it is false. This condition is false. 1 less than 0. Hello. 1 is greater than 0. So if it is false, then you can see that timestamp of 1 is greater than 0, greater than equal to 0. Then what happened? Right timestamp of Q is set to maximum of right timestamp of Q or and transaction timestamp. So what will be the right timestamp of P?
1.
Maximum 1 and 0. Maximum 1 and 0 will be 1, right? So it will be 1. After this, you got it?
Yes.
Okay.
Roughly clear.
Okay. Now, suppose transaction T1 read operation on data item B. So can you tell what will happen?
So we'll see the read is 0 now.
Yeah. So
And then
okay. So what is the transaction timestamp? See, you can see that. Okay. So let me this. P1 issue read operation on data item B. So what is the transaction timestamp of Ty? Transaction timestamp of T1 equal to 1, right? Because system is signed. So now we have to check transaction timestamp of it is 1 less than right timestamp of, we have to check right timestamp of B. What is the right timestamp of B? It is 0, right? So it is false, right? So it is false. So it will go to the next. So the 1 greater than right timestamp of B, it is greater than it is true. So then executed read operation and the set maximum of right timestamp. So RTS B and transaction timestamp of T1. So you can see that RTS of B is 0 and the transaction timestamp of T1 is 1. So it will set to be 1. After this is clear?
Yes, sir.
Okay. Now suppose transaction T2 is should write operation of A. Right? Now, anyone have to check? You can at least try. So you have to check this okay. Let me this after that. Okay. So transaction T2 here. Transaction T2 issue write operation on data item A. This is clear? Hello? See,
Yes, sir.
transaction T2 is issued right operation on data item B. So now timestamps of T2 is to, you can see that we have already assigned unique timestamps T2. Now we have to check this condition. Okay. TS of T2 will be 2 less than, then we have to check read timestamp of A. What is the read timestamp of A? You can see that read timestamp of A is 1. Okay. Hello.
Yes, sir.
Yes,
So
sir.
it is false, right? It goes to the second condition. Timestamp of T2, TS of timestamp T2 is 2. What is the right timestamp of? You have to check right timestamp of A. So right timestamp of A is 0. Then it also false. Then it will, otherwise the system execute the right operation. So it will execute the right operation and set W timestamp of A to TS TI. Transaction timestamp of T2. What is the right transaction timestamps of T2 is T2, so set to T2. Sorry, transaction timestamp of T2 is to set to T2. So everyone got up to this? Why we write true? If you have any problem, I will explain again because this is a bit tricky. So don't worry. Up to this, everyone clear?
Sir, how are you taking this read and operations considering these write A, read B, write A?
Okay.
This order.
Order means this order.
Yeah, this.
So I'm giving one example. So with the help of example, we'll see when to be roll back. So this is example, right? So
Okay.
in the exam, there will be schedules and you have to set which transaction will be rolled back. So this is just example.
Okay.
Okay. So up to this is clear, everyone? Okay. Suppose T1 want to perform read operation, right? So T1 want to perform read operation. So in this, what happen? You have to check this condition. T1 issue read operation on data item A, right? So now we have to check this transaction timestamp of T1. Transaction timestamp of T1 is 1, right? You have to check 1 less than, you have to check right timestamp of A. So what is the right timestamp of A? We can see the right timestamp of A is 2. So 1 less than equal to 2. This is correct, right? Hello.
Sir, TS of T1 is equal to 1. Where did you get this from?
Okay. When transaction T1 and T2 enter to the system, system gives unique timestamp. It can be system clock or it can be logical counter. So we give 1 and 2. So it 1 less than 2, right? Hello.
Yes, sir.
So then what will happen? The read operation will be rejected and TI will be rolled back. So TI is T1. So T1 will be rolled back. So hence T1 will be rolled back. we can see that there is a conflict instruction and T1 and T2 to A. So if you T1 and T2 and you and timestamp protocol always conflict serializability. So we can see that there is a cyclic, right? Hello.
Yes, sir.
So this will be rejected and rolled back. So up to this is clear.
Yes.
So when it to be rolled back, how to check this condition basically. If you did not understand, I will repeat once again. If you did not understand, if you have any problem. After this, everyone clear? Or shall I repeat once again?
Sir, you can repeat the first two only, means just for.
Okay. Okay. Let me erase. T1 and the T2. Why enter the system? System gives unique value for transaction of T1. Timestamp of T1 is 1 and timestamps of T2 it gives 2. It's 1 and it's 2, right? Okay. And initially write timestamps sorry. But let's like A and the B and the right timestamp. Initially all are set to be 0, right? Okay. Suppose T1 is with a read operation on data item A, read A. So we have to check this T1 issue read operation on data item A. So now you have to check this condition. Transaction timestamp of T1 is 1 less than, you have to check write timestamps data item A. So you have to check this. So 1, you have to check write timestamp of A. Write timestamp of A is 0. We can see that 1 less than equal to 0. This is condition false. You have to go to second condition. 1 greater than equal to 0. Yes, is greater than 0. Then read operation is executed and write timestamp of Q set to the maximum of write timestamp of Q or transaction timestamp of T1. So maximum of 1 read timestamp will be 1, right? So it to be write timestamp of A will be 1. Now transaction 1 to perform T2, suppose write operation. So you have to check this condition. T2 issue write operation on data item A. So transaction timestamp of T2 is 2. Okay. Now we have to check transaction timestamp of 2 is 2 less than read timestamp of A. So 2 less than, you have to check read timestamp of A is 1. You can see that 2 less than 1. Yeah, it is false. Then we have to go to the second condition. 2 less than WTS of A. Yes, it's true because write timestamp of A is 0. So now go to the last condition. Otherwise, the system execute the write operation and right timestamp of Q WTS equal to transaction timestamp of T2, right? So transaction timestamp of T2 will be 2, right? So it will be executed. Now suppose transaction T1 again issue read operation or write operation, right? Suppose read operation issue, right? Okay, now let's erase. So T1 issue read operation on data item A, right? So transaction timestamp of T1 equal to 1. Now we have to check this condition. Transaction timestamp of T1 is 1 less than, we have to check right timestamp of A. So then we have to check right timestamp of A. Right timestamp of A is 2, right? So 1 less than 2, it is satisfied true, right? So then we have to read operation is rejected and Ti will be rollback. So Ti will be T1. So Ti will be rollback. So then this transaction will be rollback. So up to this is clear.
Yes, sir.
So, and there is one Thomas Wright rule. Okay. So in Thomas Wright rule, everything is same. So just this condition is changed. This condition change. If it's transaction timestamp of Ti, if it is less than the right timestamp of Q, then in timestamp protocol system rejected write operation, but in Thomas Wright rule it will be ignored and move on, right? So in Thomas Wright rule is basically modified version of, okay, let me write Thomas Wright rule. Modified version of timestamp protocol. In timestamp protocol, all if it is satisfied timestamp protocol, all schedules will be complete serializable. But in Thomas Wright rule, all will be view serializable. Right? So if it is everything is same, but if it is transaction timestamp of Ti, if it is less than right timestamp of Q, then right of Q will be ignored. And move on. Right? Everyone got it? In timestamp protocol is very important. Thomas Wright rule is not important. So everyone got it, or shall I give one example in Thomas Wright rule?
Clear, sir.
Okay. Okay. So any doubt in lecture 10.4 or lecture 10.5 or anything in week 10, you can ask.
So this answer key for quiz 2, when will it be released?
Uh,
Hello?
Piyush sir?
Yes, yes. Like you get that quiz bundle, right? After the quiz over. I think within 1 or 2 days it will get released.
Okay.
Okay. Okay. Any other doubt in week 10? Or in any other week? Okay, no worries. Yeah. Okay. Yeah.
Thank you,
If
sir.
Yeah, okay. If you don't have any doubt, we can close this session. Yeah. Thank you, everyone. Yeah.
Thank you, everyone.
Thank you, sir.
Yeah,
Thank you, sir.
most welcome.